So hello there and welcome to the tutorial. My name is Henry Bakshi and this time we're going to be going over something pretty new, and before I continue I'm just going to recommend that this tutorial is slightly based off of my postfix and infix evaluating tutorial. So I actually created a video for that, and so I'd recommend you check that out down in the description. It'll be really helpful if you just watch that, then watch this, because it's slightly based off of it, and yeah, that's pretty much it. Anyway, continuing, today I'm going to be explaining how you can evaluate straight up infix expressions using Swift. So let's get started. And so this method is basically, instead of converting to postfix then solving the postfix, just solve as you go through the equation essentially. So let's get started and I'll explain exactly how it works while we move on. So let's get started. And so now, first thing what I'm going to do is I'm going to take some sort of random expression, like maybe something like 1 plus 2, 1 plus 2 times 4 plus 5. So now this is a pretty interesting equation. The reason I didn't just put 3 here is because 1 plus 2 is 3 anyway. So it's a really more informative if we do this way. Okay, let's continue. So again, we're going to be using stacks for this, and so again, this is going to be a quicker way to do this, since once we reach an operator, it's going to solve whatever was behind it, as long as it can with BEDMAS rules. Again, I couldn't find this on Wikipedia online in general, so I'm assuming, since I couldn't find it, no one has made a tutorial on this yet, but if you can find a name for this algorithm, please do tell me in the comments, or you can even email me at tadgymania@gmail.com, and my email will also be down in the description. Anyway, continuing. Let's start solving this expression. So first of all, let's number these characters. So the number 1 is 0, this plus is 1, actually I'm going to write it a bit bigger. 0, this is a 1. And so then, actually, I'm going to erase this. And I'm going to write it in red, so you can clearly tell the distinct difference. So now this is going to be a 0, this is a 1, this is a 2, this is a 3, this is a 4, this is a 5, and this is a 6. So this 1 is the 0th character in the expression, this plus is the first, this 2 is the second, this times is the third, this fourth is the fourth, this plus is the fifth, and this fifth is the sixth. And so let's get started. And so now what I'm going to be doing is we're going to be solving it using stacks. So let's get started. And so first thing what we do is in Swift we split this into an array, separated by each space, so that we have each and every little token. Then what we do is we just loop through that entire tokens array and start solving. So let's get started over here. And so let's just say, first of all, we have one stack in black. One stack. As you can see, the stack here. Good. So this is one stack that we have. I'm going to make one more stack for our operators. It's already starting to look quite a lot like my other tutorial. However, this is where the twist comes in. Instead of converting then solving, again, this will convert and solve at the same time, and then whatever's left it'll solve. So, let's get started, and first we have a 1. Again, whenever you find a number in this expression, just add it to the operand stack. So, in order to differentiate between these, this is the operand stack, or the number stack, and this is the operator stack. There's no other really name for it. Stack. Perfect, so this is the operand stack, this is the operator stack. So when we see a 1 over here, we just immediately say that, okay, we're going to take a 1 and push it in here. Now what we're going to do is we're going to see a plus, and since there's nothing in here, there's no things for us to do, so we just push the plus onto our stack. So we write a plus inside here. Perfect. Then we have a 2. again, this will just go straight into our operand stack. Now here's where something comes in. We see another times. Now let me explain something called priority to you. Now as you can see, we have times, divide, add, and subtract. Now we split these into two parts. And so multiplication and division have the priority of 0. Addition and subtraction have the priority of 1. And so, actually, you know what? It's a little bit confusing for someone just to see it like that. So I'm going to write it a bit spaced out. So there's going to be times, which has a priority of 0, meaning it has the highest priority. And there's also divide, which also has a priority of 0. So it also has the highest priority. Addition, not so much. It has the least priority. And so does subtraction. Perfect. So now that you know that, I can explain the rule to you. The rule is that we want to take a look at this operator. So we have a times currently. That's what we're on. Okay? In our stack's peak, which is our plus, which is the highest element in the stack, is a plus. So we note down the priorities for each. For times it's 0, for addition it's 1. Now we can see that this number over here, 1, is greater than 0. So we can say that we will not be popping out. However, for example, if its priority were 0, we would be popping out the plus and doing some more stuff. However, I'm going to be explaining that in just a minute. So now that we know we're not going to be doing any popping, we just add the times to our stack. Perfect. So now we see a 4, and so we just put a 4 onto our operand stack. Perfect. Then we see a plus, and now this is where the twist comes in. As you can see, this is basically just like my other tutorial. We're just building up some postfix. However, now that it sees this operator, no, not because it's the last. However, because its priority is greater than the one that's in the peak of the stack. So, as you can see, we're currently on this plus, and we're not on this times. We're currently on the plus. Okay? So we note down the plus's priority, which we know is 1, and we note down the times priority, which is 0. So now we know that 0 is less than 1, so what we do is we come over here and we pop the times out of our stack. Then we pop out the 4, and then we pop out the 2. Okay? Then we put them to the side and we said, okay, what's 4, the operator, and then 2 equal to? Well, we know that it is 8. So what we do is we take that 8 and push it onto our operand stack. Perfect. So now what we can do is, again, we see that I'm not going to erase this because we're still on this, because we see there's still something in our operator stack. So this actually has the same priority because plus and plus both have a priority of 1. So this is equal to 1. That means still that we will pop out and add. So what I'm going to do is I'm going to pop this plus out of our stack. I'm going to pop out our 8 from the stack. I'm going to pop out the 1 from our stack. Then what I'm going to do is, again, I'm going to put them to the side, and again, we're done this. And I'm just going to keep that there so you know we've done that. And then so we have 8 plus 1, which will be equal to 9. And so we put a 9 into our operand stack, and then we see, okay, there's a plus, and so we just put in a plus onto our operator stack. Because, of course, that needs to go there no matter what. Then we see a 5, so we're going to put it onto our operand stack. Now we realize that the question is over, so the few remaining operators that are in this operator stack we're going to apply here, just like we did in postfix, though not exactly. So we see a plus, right? So what we do, we pop out the plus, we pop out the 9, we pop out the 5, and we say, what's 5 plus 9? And so it is 14. And so it'll push 14 onto our operand stack. And then once we're done completely, there's nothing left in the operator stack, we can just pop out this value and return it. And so our answer, we know, will be 14. So that's the really basic method of how this works. And now that you know exactly how this works, I'm going to give you one more example before we do go to the Mac part. So let's do something like, maybe, I'm just going to think really quickly. That has to be something really nicely. Idea. Let's do some subtraction this time, sorry. Let's do subtraction. So something like 5 plus 2 minus 4. Perfect. So now, what I can do, draw this out nicely for you. 5 plus 2 minus 4. And so this is the 0th character, this is the 1st character, this is the 2nd character, this is the 3rd character, and this is the 4th character. Perfect. And actually, since this is actually a little bit hard to distinguish if this is actually a number or a character number, I'm going to write it in red. So again, this is the 0th, this is the 1st, this is the 2nd, this is the 3rd, and this is the 4th. The reason I'm actually telling you these character numbers, and you'll see, is in the Mac part there's a little extra feature in this app that I will be showing you that requires these character numbers. Anyway, let's solve this now. First of all, I'm going to draw a stack. So I'm just going to say stack 1, drawn, stack 2, drawn. Okay, so first of all, we see a 5, and you push it onto our operand stack. Perfect. Then we take a plus, and we add it onto our operator stack. Then we see a 2, we put it onto our operand stack. We see a minus, now we start. So the minus's priority and the plus's priority are the same. Since they're the same, we just do this. We pop out the plus, we pop out the 2, we pop out the 5. We do 5 minus 2. And we know, oh, it's a plus 2, sorry. And so we know that this will be 7. So what we can do is just push a 7 onto our operand stack. Then, again, this minus has to go into our operator stack. And then we see a 4, so we can just put it onto our operand stack. Now that we're done, we see a minus. And so since it's a minus, what we do, we pop it out of our operator stack. We pop the 4 out, we pop the 7 out, and then we see, okay, what is 7 minus 4? Well, this is going to be equal to 3. Now that we know that, we can push it back in here, and then we see, oh, this is empty. The operator stack is empty. So we could just pop this out, return it, and we have our answer, which is the correct answer, which is 3. Those are two really quick examples of how that worked, and so I actually forgot to tell you this. I actually thought of this algorithm while I actually saw those punching calculators where you can basically type 5 plus 4 plus this plus that, and it solves it while you type. And I was really confused on how it would just actually be able to solve it without knowing the entire question, without knowing that there's something ahead that has higher bitness. But since I've seen many of these, I've worked with them, I was able to estimate what a sort of algorithm would be. After a bit of tweaking, it worked, and I'm creating this video. So now we're going to be going to the Mac part, in which I will explain my entire code, a playground, and also a slight app that I've created. Again, I haven't really created a framework for this yet, but I will be making one, and it will be available for download down in the description. And it can also handle brackets. Basically, it'll just solve brackets for you. It'll solve the bracket, and instead of having the bracket there, it'll put its answer there, and then it becomes much easier to solve. So that's how that works. And yeah, let's get to the Mac part. So welcome back to the Mac part, and now we're going to be going over the code. And as you can see, I have actually brought this little panel closer to the code so you can actually see the equation and also the answer pretty much close together. So let's get started with this specific equation. 2 plus 4 plus 5 minus 3 times 2 plus 7. Pretty long. And the answer in this case should be, okay, let's take this out. So 3 times 2, we know that's 6. Then we can do it in any order we want. So 6 plus 7, for example, 13. 5 minus 13, we could do 8. For that, and then so 4 plus 8, we know that would be 12, and then add 2. So this should be around 14 for the answer. So now let's put this into our little contraption. Actually, you know what, that wasn't such a good idea. Anyway, so let's put this into our little code. And so 2 plus 4 plus 5 minus 3, 2 plus 4 plus 5 minus 3 times 2 plus 7. So let's see what this program gives us. And the answer is 12. Maybe I had an error in my calculations, but this is the correct answer because I have tested this out and it is completely correct. So let's just test this out. 6 plus 5, so that would be around 11. 11 minus 6, we know that would be around 5. 5 plus 7 would be 12. Perfect. So this is 12, and so I had an error in my calculation, sorry. But anyway, we know that the correct answer is 12, and so our program is pretty accurate. And so again, as I've said in the whiteboard part, this program does work with brackets. I have coded it to replace all brackets with their answer. And so if I were to give it something like 12 plus 10 divided by 2, as you can see, it will give 17. However, if I put brackets around 12 plus 10, it will give us 11. And this is the correct answer because 12 plus 10, that's 22 divided by 2, that should be 11. However, if we do it this way, it's going to be 12 plus 10 divided by 2, and 10 divided by 2 is 5, so 12 plus 5, which is 17, which is the correct answer as well. So the brackets in this case do make a difference, and that's how they work. In case you don't understand what I mean by replace the brackets, well, this is what I mean. If we go up here, as you can see in my bracket logic, this is the original little expression here with the brackets and stuff. After my simplification process, it is this, 22 divided by 2. And that's how that works. Anyway, now continuing, let's take a look at the code now. Now, again, as I said, it would be extremely helpful if you would just go and watch the original postfix tutorial, because there I explain stacks, I explain most of that sort of stuff, and so it would be really helpful if you would just check that out, and then so you will also find out how I calculate the precedence and stuff like that. Anyway, and also one more thing before we continue. First of all, what I'm going to do is I'm going to expand this variable once I type something in, like, what was the original question? 2 plus 4 plus 5, 2 plus 4 plus 5 minus, minus 3, okay, minus 3 times 2 plus 7. Perfect, and so now, as you can see, it gives us the correct answer, and this is all the stuff behind it, so I can just do this. and so I can also show this. So as you can see here, this is actually showing us, first of all, what characters are at what index in our array. And then second, it's actually showing us, okay, so basically, the third character, which is this plus, modified this 2 plus 4 to be turned into 6. And as you can see, these red numbers here are all our indexes. Anyway, continuing, as I said, this third character, which is the plus, actually modified 2 plus 4 to become 6. Then this fifth minus modified 6 plus 5 to become 11. As you can see here, also here, we have the 5 here, it modified this to become 11. Anyway, now at 9, we can see this plus has turned this 3 times 2 into 6 over here. And then this plus also solved for essentially 11 minus 6, which would be 5, as you can see. And then it was just left with 5 plus 7, and so it got the answer 12. And so that's how that works. Anyway, now we can continue with looking at our code. Let's continue now, and as you can see, I am going to be skipping a little bit of this because, first of all, you don't need to know this right now, and also this is completely unneeded. I was just experimenting with something before, but now it's not needed. As you can see, I have my stack class. I have an extension to the string class, which will easily allow me to get the precedence, the operator or number of any sort of, essentially, string. Another extension to the string class, which was created by, I think, Alec Larson on Stack Overflow, but anyway, the link to it will be down in the description, and so that completely works. This string extension will allow us to get a subscript of a string. And then finally, this extension to the array class, which will allow us to get something from an array and make sure that it actually exists by either returning an optional or it will return the actual value if it exists. And so what it's going to do, actually this was created by someone on Stack Overflow as well, and I will be putting their name and the link to their answer down in the description, so you can look in the description for that. Anyway, continuing, let's look at our Infix parser now. So anyway, this is our Infix parser, and first of all, as you can see, I have a function here. What this function is going to do is it's going to allow me to replace all the brackets with the actual final answer. It does this by taking each and every section of bracket, and it will basically, and also, in case you were wondering, these are the only two things that I've taken from Stack Overflow. The rest is all mine, completely. These are the only two things that were from Stack Overflow. Anyway, so this is the bracket engine. It has some nested functions which will allow us, first of all, to parse out all of the brackets, and so from the entire expression, convert all the brackets into an array of strings. So if there's like 5 sets of brackets, you want to put 5 sets of brackets into that string array. And then after that, this bracket solving function will actually return a string, which is the final expression completely ready to be essentially returned. So it will take all the brackets values and it will solve them using this solve function that I've created. And then it will replace the places where that bracket is occurring inside of the expression with the answer that it got from the solve function. So that's a pretty simple way to explain how it works. And if you want a more detailed explanation on this, again, you can always download the source code from GitHub, and this will be completely available on GitHub. I will be releasing an app version soon of this, but the playground version will be available immediately, and I will also be soon releasing an app version of the postfix and infix conversion. Just check out my Twitter, and I'll tweet you when I am done uploading that. Anyway, let's continue. So Now, as you can see, our solve function, finally. So now, this is our solve function, and we're taking the expression over here as a variable. And so this expression variable is a string, and we're returning an int due to the fact that I just wanted an integer, not a double, because it's easier for me to test. Anyway. So now the expression, so basically we are going to be removing all the brackets in this one line because we have an expression handler function. So what's going to happen is we're going to say the expression is equal to expression.characters.contains a bracket. If it does, then use the bracket engine on this expression, or else just set it equal to the expression, which is itself. And so that's how it will simplify a very complicated bracket-filled expression with a normal expression that it's nice at solving. Anyway, after that we are creating our operator stack and our operand stack. Next, after that, we are creating our tokens, which are essentially just the expression separated by each space, and that's so that we have all the different tokens, and then using that we can loop through them, check if they're an operator, check if they're a number, do some logic with them, etc., etc. So as you can see, it's converting 2 plus 4 plus 5 minus 3 times 2 plus 7 into a big array full of all of this. 2 plus 4 plus 5 minus 3, and then there's more, it's just that you can't see them here. Anyway, and then so after that, we are looping through our tokens. So we are enumerating our tokens. And so we are taking the index and the token in our tokens array and looping through them. After that, we're just printing out token at index, so it's a little bit easier for me to know what is where, just in case I want to debug. Sorry about that. And so now we can see that I'm checking if the token's a number, no logic required, put it onto the operand stack, that's it. Apart from that, if it's an operator, however, this is where stuff gets complicated. We're checking if the operator stack's peak's precedence is lower than or equal to our current token's precedence, then we want to check if not the operator stack's empty, meaning that this stack is not empty. Then create a new variable called result, and then do a switch case on the operator stack's peak. And then you want to check if it's a plus, set the result to the two values right fresh out of the stack, add them together, and that's the value in result. However, if it's a minus, you want to take the number that's one down from the first number. So what you do is you say, okay, this number, I'm not going to explain how I actually get this number, but this number is the second highest in the stack. So if 5 were the highest and 2 were after 5, and then there was many other numbers, many other numbers actually, then you would take the 2 because that's second highest in the stack. And then you can minus out operand stack.pop because that's going to be the first number anyway. And so since that one's gone, but the second highest element is now the first highest element and it's still there, we have to pop that out of our operand stack. But multiplication, however, we don't do that. That's because addition and multiplication can be done in any order that you do the numbers. Actually, in most cases it can. In some cases it can't, but yeah, it doesn't really matter for this sort of a conversation, sort of a calculator. And yeah, so, multiply and addition you can do in any order. Like you can put the number, the first number on the other side or the second number on the other side, and it'll still give you the same result. But if for a multiplication, or actually division and subtraction, you would put the numbers in a different order, it would give you a completely different result, maybe even negative numbers sometimes, and you don't really want that. So that's why we are not doing it for addition, for multiplication and addition, but we are for division and subtraction. So in division, we're doing the same thing that we did for subtraction. However, we are not basically minusing or subtracting, we're dividing. And so that's basically how that works. Anyway, if there's nothing like that, if there's not a plus, minus, times, or divide, meaning our algorithm has gone wrong for some reason, just set the result to 0. That's the best thing we can do. After that, just print out the index, but we don't need that anymore because we have result at index, meaning if there's something that's modifying something, tell me where it's being modified from and what its answer is going to be, so it's easy for me to debug, and also I can show it to you. And then I'm just printing out operand stack.self value, which I do not need anymore. But then I'm popping 1 out of the operator stack because now we've actually essentially dealt with that operator. And then we are pushing this result onto the operand stack. And then once everything is done, we are pushing this specific token onto the operator stack. And then once we're done, there might be a few operators left in the operator stack. So what I'm doing is I'm saying while not operator stack.empty, what we're doing is we are again just setting the result to 0, switching on the operator stack's peak, doing all that logic, then popping 1 out of the operator stack, and then pushing this result onto the operand stack. Once we're completely done with that, the only value left inside of the operand stack will be the final answer, and so we can just return the int typecasted force unwrapped version of operand stack.pop. That's how that works. And so then it will return our answer, and then we will be able to see our answer. So for example, if I were to do something really complicated, maybe something like random numbers and random operators at the same time. 2 plus 4 times 9 divided by 4 times 3 minus 4. Just some random thing here. 81, and let's see what Spotlight gives us. 81. So as you can see, our answer is correct, because of course I don't think Spotlight, Apple's own little calculator thing, would be wrong. Okay, so that's essentially how this Infix parser works. Again, this entire source code will be down in the description for you to download. I will eventually be making a framework for both this and my other postfix one if you want to take a look at that. Again, this is very simple to add operators. Just put its precedence in the string extension and handle it in both of these while loops. And so I will also be making app versions for both the postfix version and this version. Again, if you want to look at all that news, you can just go to my Twitter, maybe follow me, and you'll always get notified whenever I release a tweet, and that tweet will probably tell you that I'm releasing something new. And so yeah, that was pretty much it. And again, if you like my content and you want to see more of it, please subscribe to my channel. If you like this video, please make sure to click the like button. And if you have any questions, suggestions, app ideas, general education ideas, please comment down below. You can even email me a question at tadgymani@gmail.com. You can also email me a video of you asking a question at tadgymani@gmail.com. My email will be down in the description, and again, I might just feature a video on one of my next videos, and that's gonna be it. Goodbye.